We're going to start Module 5, Lesson 5 with a warm-up from Lesson 4, which we just finished. Both of these are from Lesson 4, but I thought this was more like what I would put on a test. That one's a little bit simple. So go ahead, turn off your videos, and make sure you solve, graph, and write interval notation. And you might even want to write the set builder notation down here too, just to make sure you remember that for the next class or any times Alex may ask you in this class. So go ahead and work on that and come back when you're ready to check it. For this one, solve, graph, and state and interval notation, we first have to clear parentheses. Remember, the rules for inequalities are the same as the rules for solving equations. You first have to clear parentheses and combine like terms before you start moving things from side to side. So the left side's all set to go. The right side, though, we have some distributing, and then we'll probably have some like terms as well, I'm guessing. So plus 5x minus 10. Negative 3x plus 1 greater than negative 5 plus 5x minus 10. There we go. So on the right hand side, we do have a couple of like terms there. We have a negative 5 and we have a negative 10. So that's going to leave us with negative 3x plus 1 still on the left. And on the right, put your x first, 5x, and then a negative 5, negative 10, negative 15. There we go. Now we're down to our two-step equation. And remember, solving inequalities are exactly like solving equations, except sometimes on the last step, if you divide by a negative, you have to remember to flip the symbol. So always keep that in the back of your head. So x's move to the left, just like they do with equations, and we do the opposite. Opposite of add 5x, subtract 5x. So the x's are gone from the right side, which is our goal. So we have negative 8x plus 1 is greater than negative 15. Now we need anything without an x. All constants move to the right. It looks like I'm going to have to go sideways on this one. So that leaves us with negative 8x is greater than negative 16. So at this point, I already know my symbol's going to flip because I see that negative 8 in front of the x. So opposite of times negative 8 is divide by negative 8. That is going to flip the symbol. Gee, wow, wow. I have no room to write this answer, do I? So let's go up here. Double negative, positive, double negative, positive, and immediately flip your sign. Because it's easy to get involved in all the double negatives and do the simplifying and all that and forget about the sign. So usually I flip the sign even before I do the double negatives, but I had to move it up there. So 8 divided by 8 is 1, so we get x, which is now less than, and positive 16 divided by positive 8 is 2. So there is my solution. And again, the reason I flipped the inequality is because I divided by a negative. So you can always tell when the number in front of your x is negative, that's when you're going to have to flip your inequality symbol on the last step. So no equal sign on this, which means I'm using a parenthesis, and that looks like an else, so that's less than. So less than 2. Looks like this, and you can see how important that rule is about flipping the inequality. You forget it and you're going to be shading the wrong way. Your interval notation is going to be wrong. So that one little step messes up the whole problem if you forget it. So dividing by a negative, flip the inequality symbol, and it usually only occurs on the last step. I've seen one problem in my 126 class where there's a fraction with a -6 underneath on the first step, and you have to multiply everything by -6 to get rid of it, so it flips right at the beginning. But that is the only time, I'm probably in my whole teaching life, that I've seen where you would flip the symbol on the first step. 99% of the time, it's on the last step because that's the step where you divide. Okay, so we have our negative infinity we need to put in here. Now, when you're graphing in ALEKS, you just do this. You put a parenthesis at 2, and you click right here to get it to shade. But for interval notation, we need to know what's down there, so that's why I put it in, because I'll have some students email me and they'll go, well, I'm trying to put the negative infinity in and it won't let me. Well, it's not going to let you on the number line. We just do that to help us with this step. And that's why I said I would draw the graph on your paper before I draw it in ALEKS so that you can do this step more easily. Number one most missed thing in both this class and my 126 classes, students don't put these in the right order. And that's because 1, they either don't graph it on their paper, or 2, they wait and graph it in ALEKS on part C so they don't have it to use for part B. Because this question is before this question in ALEKS. So that's why you should draw it on your paper. Then you'll always get this one right. The left endpoint's negative infinity, which always has a parenthesis. The right endpoint is 2, which has a parenthesis because of no equal sign. So great, great, great one to study for your test. I believe I put 2 of them on the test. But yeah, it's a good one because it has a little bit of everything. It has the parentheses, combining like terms, having to flip your symbol, the graphing, the interval notation. Good little problem there. Okay, so we are ready to start page 13 in our note packet. And you may be asking, why did Miss Norris write on Canvas only copy the first 18 pages? And the reason why is I was looking over 19 and 20, and they're all stuff from Math 126. You're going to learn it in that class, and so that's why I cut off the last 2 pages. It was motion problems and work problems, and those are things that we're going to do in the next class, so there's no need to learn it twice. Okay, so this is page 13 of the lesson 2 through 5 packet that was posted on Wednesday, January 29th. So we're still in that second packet. So this is going to be our introduction to problem solving, or in this class they call it mathematical modeling. So the steps for solving word problems, obviously, read the problem. If it's a geometry problem like a rectangle, a triangle, something like that, make sure you draw the picture. Pictures are everything, especially in geometry. Write down all the important information. What have they given you? What are you trying to find? Then you write your variable statement after you know what you're trying to find, just like we did on the last video when we were doing the word problems. We found that we were trying to find the number of people, so $32 times every person. So the minute I wrote it there, I went up there and said P equals number of people. So once you figure out what it is you're looking for, then you write your variable statement. And X is just generic. Remember, you don't need to use X. I just used it as an example. Use a letter that represents what it is you're finding, just like P for people. So then we write the equation for the problem, which we did that on our last 2 here as well. Wrote the equation either by direct translation or by reading the problem and writing the equation or inequality there. And then you can solve. Make sure your answers make sense. I've had some crazy answers. So I had this girl, I used to teach at PVCC, And she got two answers for this problem, and it was the speed of the current. And she had an answer as, I think 5 was one of them, and another one was -2. And she circled the -2. So to me, that showed she has no idea what she's finding in the problem. So always know what your variable represents, and always look at your answers and decide which one makes sense for this scenario. Water is not going to travel at -2 miles per hour. So, and she was someone that had really high anxiety. When I showed it to her after the test, she's like, oh my gosh. She goes, I was so anxious because it was a word problem I wasn't even thinking. But you can catch a lot of errors by looking to make sure your answer makes sense. So I've written down some keywords here. A lot of students tell me that they copy these and put them in their notebook. You know, they take a picture or print them or whatever, or cut out this page. I mean, if you don't have words on the back, anything on the back, you could cut this out and they just paste it in their notebook, very front cover, so they always have it to look at if they have a question about it. So words for addition, we already learned sum is the big one. Just like for subtraction, difference is the big one. Product for multiplication, quotient for division. So when we were doing our translating, we learned about those 4 big ones. Now we're going to learn about other ones, more than you've already seen in your translations. So that's a plus. Plus is increased by, is addition, added to, obviously. Total's another one that's pretty common. And obviously add. Subtraction, the most common one, as I said, is difference. They can always say minus, decreased by. We saw this one a lot. Subtracted from, and less than. So these are the ones we see the most. Subtracted from, less than, fewer than. We saw a lot of those in our translations section. And subtracted by. And we're going to see like how these affect it, because I have some listed here that just are different by a word or two, but they're totally different when you go to translate them. Probably the 2 most common one in multiplication are product and of. We already ran into an of problem. I think we were doing a warm-up, and it was, yes, right here. 14 of our warm-up, 2/3 of the number. So that means 2/3 times the number, which we called x. So we've already ran into that, but of is very common. Other words for multiplication, times, multiplied by. We've seen these 2. Double, twice, triple. We've already seen those in our translations. That means 2 times x, 2 times x, 3 times x. So when they say double the number, that means 2 times the number. Twice the number, 2 times the number. Triple the number, 3 times the number. And division, they don't really use too many besides quotient. Once in a while you'll see per, like dollars per hour. That means dollars divided by hours. Miles per hour, miles divided by hours to find your speed. So when we're doing speed, lots of times that will be the per means division. So it's kind of a big one too. I'm going to circle it. But unless you're doing like rates and ratios and speeds, you don't see per that much. Divided into, divided by, which by the way mean 2 different things. 2 divided into 3 would be 3 divided by 2. 2 divided by 3 would be 2 divided by 3. So although the words are very similar, they're different. So 2 divided into 3 means the 2 goes second. 3 divided by 2. But 2 divided by 3, you just do a direct translation. Or you could say, how many copies of 2 go into 8. Or you're going to split 8 into groups of 2. How many groups will there be? So split up is another one. So, okay, so since we're pretty much experts, I think you guys are. I hope you feel like you are too. Since we're pretty much experts on the translation, I want you to try those 5 first, all by yourself. You've seen them all already, but I just want to make sure you understand the difference. And usually it's just a word. So shut your video off, answer these 5 questions by translating. So translate what it looks like, and then turn the video back on, and we'll check them, see how you did. Great practice problems, right? Yes, very good review of what we learned in lesson 1 and then again in lesson 2. So we learned less just means subtract. It's a direct translation. 7 subtract 10. So anytime you see the word less, just another word for subtraction. So 7 subtract 10, 7 less 10. This is 7 less than, and we learned when something's less than, that means the 7 is being taken away from 10. So this would be 10 minus 7. And order matters. The answer to this one's -3. The answer to this one's +3. So that one we've worked on more than any other. Less than mean that number goes at the end because 7 is being taken away from 10. Okay, so now let's change that one with just a tiny word added. Whole, different, ball game. Is less than, we learned, means an inequality symbol as long as all 3 words are uninterrupted. So 7 is less than 10. So see what I mean? They add one tiny little word. Here they added the word than. Here they added the word is, and look how different they are. So 7 is less than always means, or is more than, or is greater than, always means an inequality as long as there's no interruption in those 3 words. They have to be all in a row. So 7 is less than 10. Here's that from. Practiced on quite a few of those in the last lesson. So that means 10 has to be listed first. 7 is subtracted from 10. So these two are the same. 7 subtracted by 10. So look how one word was interchanged, and now it means this. 7 subtracted by 10. So you have to be really, really careful with these. One little teeny word and you can have it wrong if you miss it. So great ones to study right there, because that's like kind of all of our stuff in a nutshell from the translations. Not everything, but really good ones to study. This next part is also a review for you. So you have already been introduced to this. The difference is when we did this, they didn't ask us to solve the equations. On the next page, they're going to ask us to solve. When we did it on page 6 of our notes, they just asked us to write an expression. They didn't say the sum of the first 3 integers is 34. That would have been equals 34. They just said write an expression, but it gave us practice. So let's rewrite everything we wrote there just to remind ourselves how to find it. So when they say, for instance, 3 consecutive integers, as I showed you when we did this before, I just pick 3 numbers that match that. Consecutive integers means right in a row. And then again, to remind you, because just sitting here and going, oh, I'm just going to memorize these. That is the worst thing you can do in math, is memorize. You need to understand where these come from. You'll remember it forever if you understand. Memorizing, you'll be lucky if you remember it through the test. What about the final? What about the next test? So it's much better to understand. So the first number's x, as they said, and then we say, what do I do with 1 to get to 2? Oh, I add 1. And what do I do with 1 to get to 3? 1 plus 2. I add 2. So there's no need to memorize this useless information. I can derive it every time, and I'll never forget this. But if I try and memorize this, I'll probably forget it by the next day or two. So I always say deriving something is the best way. Okay, for even, just pick 3 even numbers. Like I said, I always pick the little ones. They're even. They have to be in order, consecutive. So 2, 4, 6. So you follow the pattern. X is the first one. What do I have to do to get from 2 to 4? Add 2. What do I have to do to get from 2 to 6? Add 4. And look at that. No memorization needed. And even after all these years of teaching, I do that at the beginning of every problem. Because you'll see you have a lot of stuff you do have to memorize in life. Save room for that when there's not a way to derive it, like the quadratic formula. In the next class, it's x equals the opposite of b plus or minus square root of b squared minus 4ac all over 2a. So that's something my students have to memorize. So do you know what I do? I say, go on to YouTube. There's some songs on there, and you listen to a song about the quadratic formula, you'll never forget it again. So there are times when you have to memorize, but this is not one of those. Okay, so this one went here. This one went here. And then the odd ones we did on that other page too, but we'll do the same thing. So odd numbers right in a row, 1, 3, 5. So the first one's going to be called x. What do I have to do to get to 3? Add 2. X plus 2. What do I have to do to get to 5? 1 plus 4 is 5, so x plus 4. So this is usually surprising to students. So they're like, what, wait a minute, 2's not an odd number. It doesn't say 2's an odd number. It says that odd numbers, you have to add 2 to get to the next one. So this one really surprises students that they're the same. But aren't all even numbers separated by 2? Add 2, add 2, add 2 to get the next one. Same with odd. Add 2, add 2, add 2. It's the x that's odd, not the 2 and 4. This just says you add 2 to get to the next odd number. Add 2 more to get to the next odd number. So x, x plus 1, x plus 2 are consecutive integers. Even and odds are both x, x plus 2, x plus 4. Okay, we'll come back on the next video and do the next page that goes along with this. See you in a bit.